Okay, verifying a trigonometric identity. So on this one, we want to start with the more difficult of the two sides. And to me, the left-hand side looks quite a bit more difficult than the right-hand side, although they are very similar. So what I'd probably get going on this, I would rewrite everything in terms of sine and cosine. You may take an alternate method of going through this, but I notice I'm going to start with the left-hand side. I have these secant squareds. I would rewrite these in terms of cosines. So secant squared, secant is 1 over cosine. So if I did secant squared, it's 1 over cosine squared. So I'm going to replace that secant squared in the numerator as well as the secant squared in our denominator. Again, not the only way to go about this. But I always like just using the formulas that involve sines and cosines. It's easy to memorize a few of those instead of the ones that involve secants and cosecants and cotangents, tangents along the way. So it's cutting down the number of different formulas you have to really be aware of and be comfortable with. So I've replaced secant squareds, each with 1 over cosine squareds. We've used the reciprocal identity to do so. And I'll try to identify these as we go along. The next thing that I notice on this is we have fractions inside of fractions. Not where we want to be, so let's work on getting rid of the fractions inside of fractions. The real problems are these little fractions that we've just filled in, and that's a bunch of dividing by cosine squared. So what I'm going to do to eliminate all that is I want to multiply by cosine squared of theta. So I'm going to do it once in the numerator and once in the denominator. As long as I do the same thing to the numerator and denominator, I'm going to multiply both of them by the same thing. It's really multiplying by cosine squared over cosine squared. That's like multiplying by 1, and that's not going to change the overall value here. So that's a legal math move to do. Okay, the next thing I'm going to do is go ahead and distribute this cosine squared to each one of these terms in our numerator. So I need to multiply this fraction by cosine squared. So that's going to give us 1 over cosine squared multiplied by cosine squared. And then we also have cosine squared multiplied by 1, which will be cosine squared. So just a little bit of distributing there. And in the denominator, we have 1 over cosine squared theta multiplied by cosine squared of theta. Now I'm taking my time and trying to show my work as we go through this. If you can simplify a little bit faster, that's perfectly fine, of course. But what happens here is we have multiplying by cosine squared, dividing by cosine squared, or that's like cosine squared in the numerator, cosine squared in the denominator. Those are going to simplify down. And this first part's all going to make a 1 minus the cosine squared of theta, bringing that along. And for our big denominator here, again, pretty similar. We're multiplying by cosine squared and dividing by cosine squared. That creates a 1. So our overall denominator here is also going to be just 1. So really we have 1 minus cosine squared of theta. And from here, we're actually pretty close to where we want to be. However, we want to end up with sine squared of theta. We're going to have to use the Pythagorean identity. So the Pythagorean identity, that goes as cosine squared of theta plus sine squared of theta equals 1. And it's a pretty good indication whenever we have squares attached to sine or cosine that you want to pull out the Pythagorean identity to help us out. So I want to replace 1 minus cosine squared. So to get there with the traditional Pythagorean identity, we're going to move the cosine squared to the other side and rewrite this as sine squared of theta is equal to 1 minus cosine squared of theta. And we get there simply by taking this cosine squared, subtracting it over, moving it to the other side. So by the Pythagorean identity, we can replace 1 minus cosine squared with sine squared of theta. And again, to go from between these two steps, this is the Pythagorean identity shorthanded up there. And that's exactly where we wanted to end up, is we wanted to show that all of this left-hand side was equal to sine squared. And that's exactly what we've done. So as you get going on these, I always suggest rewrite everything in terms of sine and cosine. Then it's a bunch of algebra to reduce things down. And then sometimes whenever you have a square involved, you want to pull out the Pythagorean identity to help you rewrite it in terms of either sine or cosine. All right, hope this helps out. Keep practicing. You'll get the hang of it. Just takes practice. Good luck.